class will talk about the exciting future explorations into space by NASA and SpaceX missions, culminating in visiting and possibly colonizing Mars. But first, we'll get the other arrangements out of the way. There's just no way that I'm going to sell out, and no way that I'm into corporate materialism, and that's not my style. I'm not that kind of guy. No way, I have too much integrity to deal with any of this stuff. So we won't be talking about Milky Way Mars, water on Mars. Let's see what water on Mars, okay, and all the jokes out of the way. Don't talk about Bigfoot on Mars, or a Volkswagen on Mars. Instead, we'll have an introduction to Mars, NASA and SpaceX plans, the logistics of getting to Mars, travel to Mars, colonization of the same, and looming challenges. And on my trusty blackboard here, we got some ideas that I'll present to you. So, let's start. Mars is 143 million miles from the Sun, or between 35 and 60 million miles from Earth. It orbits the Sun in 687 Earth days, or 2 Earth years. It is red because of the iron oxide in the soil. Mars is the same age as Earth, gets closer to Earth every 26 months, and is less than half the size of Earth, and has the same amount of dry land as Earth, obviously less oceans, and it has about a 24-hour day. And it has 2 moons, Phobos and Deimos next to it. And Mars, however, died over 3 billion years ago, as scientists think that the core of Mars solidified, taking away its planetary magnetic field. So inside the core of Mars, there should be molten iron that goes in a circle, but this all solidified, and that would cause a magnetic field protecting the planet, which is what we have here on Earth. It take away its planetary magnetic field. In contrast, Earth's magnetic field is generated by electrical currents due to the motion of convection or heating currents of molten iron and nickel in its core, making an atmosphere or protecting it. You see, major solar storms were more prevalent in the early solar system years. Solar wind from the sun, has temperature greater than 1,000,000 degrees and travels in all directions at 500 miles per second. The solar wind is like a huge river of charged particles that flow out. Imagine Mount Everest coming toward us. The solar wind blew the Martian atmosphere completely away billions of years ago, and stripped it away because it wasn't a magnetic field. And it lost its magnetic field. However, on Earth, this wind is held at bay. But Mars only kept its magnetic field for the first 1 billion years, and then it was easy for the upper layers of the atmosphere to have boiled away into the vacuum of space. So billions of years ago, these storms gutted the Martian atmosphere, leaving a dry, desert-like, barren, cold, and sterile world. Mars' atmosphere is 96% CO2, carbon dioxide, and about 2% nitrogen. However, on Earth, CO2 is less than 0.5%, and on Earth we have 20% oxygen and 78% nitrogen. But on Mars, it's completely different. So 4 billion years ago, Mars was once like Earth. But it was once like Earth, but now it has a lack of atmosphere, and a lack of atmosphere because of its magnetic field was stripped away. There's heat loss, no standing water on Mars, no oxygen, no water cycle, no solar radiation problems, and it's difficult to land on. Let's get into this. So, not like Earth, Mars was like Earth. It had plenty of water, it was warm, and had an atmosphere. Mars once had rivers, as you can see here, lakes, and a small ocean, but today it has an atmosphere so thin that its surface pressure is 1/100th of Earth at sea level. Mars therefore cannot retain or trap its heat or keep any standing water. Any liquid water on Mars would sublimate, return to gas, and evaporate within minutes. In the summer, during the day, it might reach 60 or 70 degrees at the equator. However, at night, it drops down to below 60 below zero, or 70 or 80 below, as heat escapes and quickly dissipates into space at night. At our poles, it is much colder, hovering about 200 degrees. Mars once had a large ocean, about this, the large size. One obvious signs of ancient lakes, river deltas, craters filled with water, and massive flooding with large rocks like these here that were tossed about with voluminous amounts of flowing water eons ago were apparent, but not anymore. Water on Mars is locked up in soil as permafrost, or is seen at the North Pole, where thousands of square miles of top layer ice and frozen white carbon dioxide can be seen from space. Sometimes brine-like water oozes out from crater slopes. However, robotic rovers have found no conditions favorable for microbic life, and with no life found, past or present. Currently, the 1-ton Mars rover Curiosity is in the Gale crater, and now it is ascending Mount Sharp, which is a 3-mile-high mountain that was formed by sediments carried by ancient water. The other newer rover, Perseverance, that landed in February of this year, is in the Jericho crater that was once filled with water that entered via a river that left a large fan-shaped alluvial deposits. So this is Perseverance, and we saw it land coming down with thrusters. It weighs a ton. It cost $2 billion, and looks like this. It has a pack full of science experiments, 6 wheels, nuclear powered, and has a robot helicopter named Ingenuity that has flown. And there are 8 functioning spacecraft on Mars, 5 in orbit, and 3 on the ground. And actually, China has a Mars rover also in Utopia Planitia in the northern hemisphere. And what they're really rovers are looking for is cyanobacteria, and that would mean algae, a one-celled organism, but they won't find any of this because there's no life there. However, they might find, and what they're looking for is fossilized life, fossilized algae, like here, and maybe fossilized microbes. But as the years and months and years pass by, clearly this gets dimming of hope for any kind of fossils or past life found. So it looks mainly like this, really a planet frozen in time 3 billion years back. Little blue pebbles in the rocks are from accretions from a stream that was once there. Mars has some fascinating geological features like Mars Marineris. It's a 3,000-mile long canyon that was 3 to 5 miles deep and makes the Grand Canyon look like nothing. This is so big it might have looked like this, our conception of it, but if it's so big it would be put in the United States, it would cover all the way from the west coast to the east coast. And this is really a fracture on the Mars tectonic plate. It's so big. And it has the solar system's largest volcano, Mons Olympia, which is the size of the state of Missouri, is 16 miles tall, 90,000 feet tall, 2.5 times taller than Mount Everest, and peaks into the Martian atmosphere. It's so tall. Peak in Martian space above the atmosphere. And it has Eckes Chasma on Mars. It's not a long canyon, it's about 60 miles long. But what I like about it is that when the river was flowing, when there was water on Mars, it would go over some cliffs. This cliff is 2.5 miles tall, and it would have been a 2.5-mile waterfall flowing on Mars. And that just blows my mind because the tallest one on Earth is a 1/2 mile tall at Angel Falls in Venezuela. So that's the power and how much water that there was on Mars. And Mars did have a small ocean, about 3 times the size of the Caspian Sea, and it was up to over 3,500 feet deep in some areas, and covered this kind of area. It's called the Drina Basin on Mars. And even craters were once filled with water. So it did have all those flowing features of water to know about. And Mars's polar ice cap has 2 of them, and if the northern pole melted here, it would cover the entire planet in 36 feet of water. So this is water and frozen CO2. So remember that guy back in '66 that had a mobile flip phone that could call his ship? Well, that sounds like old hat today, and that was science fiction then. But if you put in, it's really a bold idea, a fantasy, or science fiction itself can create these kind of new ideas that come up. And if enough energy, creativity, manpower, and money are put into it, it can become a reality. So why not go somewhere else? Why go to Mars? Well, why not go to Venus? Well, Venus is about 20 million miles away, but it's 860 degrees on Venus, and the pressure is 92 times that of Earth, or 92 times 14.7, which is 1300 psi, so you'd be crushed and melted within minutes. Nothing has lasted on there with our probes going there. Well, why not go to Jupiter? You go to Jupiter, you'd be crushed, and there's no surface to land on Jupiter. It's just a big gas ball. And how about the moon? Well, there's really no possibilities of fossils on the moon, but there has ice been detected in craters, particularly at the South Pole and the North Pole. They have enough water on the moon to supply 240,000 swimming pools worth of water on the moon. But we're not sure how that ice is found. So that's why we're going to be talking about how to explore for that. And there's another place we can go to that's not too far from here, but there's really no life on it past 8:30 at night. So, NASA, armed with its 17,000 employees, has developed a three-pronged plan for first astronauts to land on Mars. It's collecting data with ISS astronauts to see how they live, work, and cope in space. Here, they've sent 240 astronauts there in the last 22 years. And other countries have been contributing as well as they are for 2 decades now. Secondly, it is testing new deep space habitats and special crafts prior to sending manned missions to Mars. And the third stage is habitation of Mars, or Mars independence, to be able to stay successfully on the red planet for some time. The long-term plan will be done in stepping stone stages to ensure safety protocol. So how do you be an astronaut? Well, they go through rigorous training for safety procedures, technical aspects, and health maneuvers to learn complex and simple tasks for long-term missions. They train on things like this that you may have seen, taking tours. They train underwater for spacewalks, and this is how they get on a spacesuit. They are tested psychologically, physically, and you need to have more than one degree. You need to have like a degree in physics, biology, and other related sciences, so you can be multitasking when you go up there. And now they want fit people, they want smart ones. So the journey to Mars, we're going to take the next steps with NASA first, and then we'll talk about SpaceX. So this is NASA's plans for getting to Mars. First, with the NASA version, they will use the Space Launch System, or SLS, that will be used between now and the end of the 2020s to take steps to eventually go to Mars. It's a heavy launch vehicle that provides the foundation for human exploration beyond Earth's orbit and will carry the Orion spacecraft we'll talk about. The first SLS, or Block 1, which is what this is called, has 4 RS-25 liquid propellant engines and twin 5-segment rocket boosters. It uses liquid hydrogen and liquid oxygen to go up. Liquid oxygen liquefies at 260 degrees below zero, and liquid hydrogen at 290 degrees below zero, and there's a reason why we're going to be talking about that. However, it could take more up than the old Saturn V. It's capable of lifting 27 tons, or 52,000 pounds, which is its payload, about 53,000 pounds. It is 320 feet tall and weighs 5.5 million pounds fuel. It has 8.8 million pounds of thrust and provides 20% more thrust than the old Saturn V. So it can take more up. That's because of lighter materials, better technology over the years, and more efficiency. And this is called SLS, and this is what it'll take to the moon. Let's take us to the moon, this SLS. The cargo version is next door to it in Block 1, and it has a fairing on top to get through the Earth's atmosphere that will take cargo to the moon around that also. There's also the SLS Block, the 1B right here, and the 1B is not built yet, but it could take up to 41 tons, or about 83,000 pounds, into deep space, including the Orion capsule, crew, and cargo for sustained presence on the moon. So this is block 1. This will be a heavier lifter. and this will be the cargo version of it. And next to it is the Block 2. And the SLS Block 2 will take astronauts to Mars and can lift 100,000 pounds into space. That's 50 tons, but it still needs to be built. And it will have 9.2 million tons of thrust and be 365 feet tall. That's over a football field and a third, and weighs 6.5 million pounds loaded. So these are the different kinds of rocket ships, but the Block 2 right here will take cargo out to Mars. What can you do with it? This is how they stack up. The SLS Block 1, looking here, compared to the Saturn V, and compared to the Block 2 to go to Mars for the cargo version, compared to other even the Falcon Heavy, which is SpaceX. And this is what it'll be like going into space when it goes up in 3 months from now. Boosters will fall off, and this will go on with the Orion capsule. This is how it was separated in place with the Block 1. The main part where it holds the fuel will be here. The boosters will fall off, and the Orion capsule will go out in space either alone or with astronauts in it. The Block 2, the one that goes to Mars, same situation. The boosters will fall off, and it'll take cargo to Mars with the Block 2. That'll probably be built next decade. And this is SLS Block 1. This will be known as the Artemis program. And this is what she looks like. And it has the 4 engines that we discussed, giving it the power and thrust it needs. This is the Orion compared to the Apollo version. And the Orion weighs 31,000 pounds. It can hold between 2 and 6 people, but will hold 4 for missions. It weighs 15 tons, and it's more efficient than the other one built to go to the moon. And this is what it looks like. The Orion is about 3.5 feet wider than the old Apollo version. Many of us have been to museums where we've seen the old Apollo ones. This is the new one that I've seen. Went on a journey onto the museums shown off. This is the heat shield onto it, and this is what it takes to come back into the Earth's atmosphere. You have to go in backwards or butt first, and it looks like this. And this will be the Orion going out in space in February. And these will be astronauts going into the Orion. This is inside the Orion. And this is the interior of it. It replaces the 2,000 switches that were in the Apollo version, which had the same computing power as a small handheld calculator. So obviously things have changed, and it looks like this. This will be digital, and this was the Apollo, which was analog, and all these switches they had to flip all the time. So that's the difference between the two. This will be inside of it, when they go inside of it to do this. And so NASA's plans are February, 3 months, an unmanned test flight beyond the moon. In 2023, carrying 4 members beyond the moon. And in 2024, astronauts landing on the moon. 2026, capture and land on a small asteroid. And in the mid-2030s, the manned mission to Mars and Mars habitation. And yes, we will get into this right now. So the first one, they have plans for increasingly more complex and sophisticated missions to the moon, and Mars, and beyond. The maiden flight for Artemis 1 will be in 3 months with an uncrewed Orion capsule using the SLS Block 1 for 7 or 8 days around the moon to test module entry, safety flying, evaluation, and assess systems. It's a robotic flyby. And what that means is unmanned, it will go around the Earth a few times, which is 25,000 miles. It takes 90 minutes, going at about 18,000 mph. And then go around the moon, which is 242 miles from us, 250,000 miles, go out to the moon, circle around the moon, and circle about 40,000 miles out, and then come back, and then repeat, and then land, a robotic way of doing this. This could take a week. They could extend the mission if they want, and they could go further out from the moon, etc. This will be about 600,000 miles, and they want to test its wings, but they want to do it safe, some of them with her. And in August of 2023, Artemis 2 mission will take the first crewed mission carrying 4 astronauts from one of these groups here and travel again beyond the moon for 7 days. This will make it the first crewed mission to go beyond LEO, which is low Earth orbit, and to the moon since 1972. So we'll take the same trip the robotic system did, and we'll put people inside of it and see how that goes. So that's step 2 of the Artemis program. So step 3 will be in October of 2024, when Artemis will be used for the first crewed lunar landing since 72 using the Orion capsule for astronauts. The Artemis will use Block 1 with 3 different missions to the moon. It will send Orion capsule, cargo, and astronauts to the moon, reaching over 20,000 mph. And a man and woman will land on the moon. And what this is going to look like is they're going to land on the moon with the HLS, the human landing system that SpaceX is developing right now for $3 billion. They won the contract. And that means that, I'm going to one of my drawings here, the Orion will come to the moon and will help 4 astronauts, and 2 astronauts then will go into the HLS, the human landing system, and depart from it and land on the south pole of the moon, where they will stay for about a week. And let me go into more pictures of this, it's a lot better. The south pole of the moon being down here. And it will look like something like this. And on the south pole of the moon, where there's sunlight for 5 straight months, they will be able to take samples and see about water content in the soil and try to look for a possible moon-based situation. So it will look something like this. And the HLS, human landing system, will probably have solar panels on it to keep it powered on the moon. Remember, it's 250 degrees on the light side of the moon and negative 250 degrees on the dark side of the moon. So they'll have to have air conditioning and be able to work their computers, and as well as maybe even make water, which we'll get into. That's what these solar panels are for. They will do experiments there, and then they will blast off, and then they will reunite with the Orion with 2 people in it, and it'll become 4, and they will all come back and go back to Earth. So that is their current plan for landing on the moon. And it might look like something like this, what they're going to do on the moon with astronauts on it. And here is the Artemis core stage right here. That's where all the liquid oxygen and hydrogen are located in it. And this is the Orion capsule, which the astronauts will be in. And so what it looks like, this will be attached to the SLS Block 1, which will be down here. And you might need some kind of if you go into space for a long time, you might need a habitation module. No one can live in a Orion capsule for a week, 2 weeks, 3 weeks. No one wants to live in something the size of a table. So what they might do is have a habitation module. In other words, the Orion being the car in front of it, and it'll be dragging a wagon behind it, or like a cylinder behind it with a habitation module. And we'll need all these components in it so the astronauts can live in space, and we'll have solar panels on it as well. Let's take a look on this to see what I mean. So it'll be, this is the Orion, and they might slip into this kind of habitation module in the back of it, which will have sleeping quarters, a place to store spacesuits, a place to exercise, places to eat, to store food, to have computers on it. There's 55 computers on the ISS, by the way, and it all needs power, so it will have to have these solar panels on it, which was on my thing here, to be able to do a number of activities, particularly power, not only power, but to make oxygen. So how they do that on the ISS, the space station, is they take water, they have hundreds of pounds on there of water that they brought up, and they put an electrode in, and they're able to take out the hydrogen from it with the oxygen through a process called electrolysis and store the oxygen in a tank. Again, the habitation module will look like something like this, and will look like this, or like this. So this is how they do it right now on the ISS. That's why they've been so long up there, how to test it out. And in this habitation module, they're going to need all these things. No sense talking about it without being super specific. They need to store food and water, ability to make and store oxygen, an exercise area, sleeping areas, toilet and personal gear, table space and window, spacesuit storage, safety equipment, tools, spare parts, space for computers and monitors, lighting, heating, AC, something to get rid of the carbon dioxide, and solar panels, fuel, and sensors in something like this. So that's what the habitation module for extended trips might include.
Question?
Go ahead.
Yeah, well, when they're doing electrolysis, what are they gonna do with the hydrogen they generate?
With the hydrogen they generate, they put it into space. Yeah, they can put a lot of things in space, including any waste products, by the way. It's true. So, they have other activities too, NASA does. They want to have a self-propelled robot called Viper to be sent to the moon to search for water in craters, in deep craters and under the surface. This will be used to detect where frozen water occurs on the moon for future mining and water resources to eventually build a moon base there. We're not sure if the water's in frozen like ponds as big as this room, big as this room, or ponds as big as this complex here. But it might be interspersed with the soil on the moon. We're not sure, and that is the reason why they have Viper. It'll be a 3-month mission, but usually these missions are extended quite after the fact, and it'll be solar powered. Here is where the water can be located, particularly on the poles of the moon. Like I said, there's quite a bit on there, but it's one thing to have a chemical analysis, another thing to be able to use it directly. And then they're going to have the ARM, which is the Asteroid Redirect Mission, in 2026 to use an unmanned robotic probe device powered by solar electric propulsion to pluck a house-sized multi-ton boulder from a nearby Earth asteroid and then haul it into lunar orbit using solar power, taking it with them and taking it like this, and then placing it around the moon so astronauts can practice walking on it. In the future, astronauts can literally go to this small asteroid that they took the bolt that they have and practice on it before they go to Mars. So the moon will have a mini moon around it that astronauts can practice on using this kind of device. This is being developed right now. And then they have the Gateway, or the Lunar Gateway. It's a planned space station in lunar orbit intended to serve as a solar-powered communication hub and short-term habitation module, science lab, and holding area for robots and rovers. It would house no more than 3 astronauts. It'd be like a mini space station. The purpose would be to help build it. The purpose would be to help it as a way station for astronauts to live on the moon. And many parts of it were built by different segments of the ESA, European Space Agency. And my pictures here will always have an Orion capsule docking into it. So it will look like this. Again, remember that one that was on the moon looked pretty much like this? It'll be stuck here, and there won't be very many astronauts in it, but it'll be a helpful station out there. See, the ISS space station will be phased out by 2024, so they want to have another space station going on around the moon to help with logistics. And the ESA, of course, has contributed. This will be like a Lego set with modules, solar panels, and necessary equipment carried from Earth to be put together piece by piece. And will look like this on the center. And we'll look, here's the Orion hooking into it. And this is the Chinese space station. They just developed one, and there are astronauts in it right now, and they're trying to make it bigger, and they have about 2 astronauts in it. And they are a major contender right now in the space race. China has a rover on Mars, a solar-powered one on the moon, and now a space station. Big player. And this will be the Gateway, the Orion docking into it. I wanted you to get a sense of this, that's why I have so many illustrations of it. It's a wonderful idea. This will be put up in the late 20s, hopefully. So, by 2023, the first robotic rover on the moon, the first manned mission to the moon by 2024, and then the beginning of a moon base, that would be the gateway going around the moon in 2028, and a moon base, and this is where it gets fun. The moon base will be on the south pole of the moon, like I told you, with the sunlight for 5 months. When the sunlight goes away, they're going to have to, for 6 months, they're going to have to not live there because it'll be too cold, and you can't generate any electricity from the solar panels. So at the equator on the moon, it is one day on the moon there is 28 Earth days, or 2 weeks of darkness and 2 weeks of sunlight. So that's why you want to stay on the south pole of the moon. Anyways, you're going to need hundreds of these solar panels here to make this work out, to be able to provide enough energy to do all this work. You might want to live in these habitation modules, similar to what I told you, like this. But in order to do all these kind of things, you want to maybe put lunar soil above one of these things to protect it from radiation, you're going to need a whole bunch of heavy-duty equipment. Well, and oxygen-based systems for, the kind of cars we have here on Earth do not fit on Mars, on the moon, because there's no air on the moon, so you need to have something that's battery powered. So they would need a whole bunch of, everything would have to be done with batteries for these kind of machines to be able to make mounds like this. On the Tesla, it's 100 pounds of lithium to be able to get the car running. So I'm not sure if this can work, maybe. This would be a technological achievement, having these kind of machines on the moon to make these kind of structures. Now, they have a greenhouse effect. We don't know of any panels, greenhouse panels, that would be thick enough to help protect it against the radiation coming in. And it would have to be cooled with air conditioning from power from here. This whole thing depends on the solar arrays right here to be able to do this. And you would have to move your plants after 5 months of being on the moon to go back up, probably somewhere else. And it might look like this from a different angle. Look like this. See, on the ISS, it powers, has about 230 kilowatts, which is enough to power about 70 homes. So you would need that kind of power from these kind of arrays right here to be able to do all these technological achievements to get away with this. It might look like this on the inside and like this, but you would need more solar panels like this on the south pole of the moon for the moon base. It might look something like this. And I don't think you want to be on the moon at night in terms of darkness, because you need an awful lot of energy to be able to sustain all these lights. And it would be very, very cold. If it's 250 degrees below zero, does anybody know anything that works at that level? I sure don't. Where you used to come from, back up north, if it got below zero, 10 degrees below zero, nothing worked right, did it? Car doors don't open, pipes freeze, cars don't work, people aren't out, birds fall from the sky. So you probably want to be in the sunlight area, but I wanted to show you this illustration. But that's why it'd be very difficult to work at night, because you would, on the nighttime part of the moon, or the dark side of it, because you need all this power, which you wouldn't be able to get. But it might look like something like this, modules that you can take up in the cargo portion of the SLS that I showed you. And the ESA even has ideas. I call them hobbit houses. They remind me of hobbit places in the rings. But they'll look something like this. So NASA has all these plans. I have to read this. They go from the Hubble Space Telescope to the ISS, space launch systems, to orbiters, landers, commercial cargo and crew, the Orion spacecraft, the solar arm situation to get to Mars. So they have all these programs. This is all to get to Mars. So what was once considered science fiction back when you and I were growing up with hokey movies like this is now our reality. And what used to be this can be this. And this is to talk about the future on Mars. And it might look like something like this. But they might have local opposition out there. There might be strong protest movements. Local candidates there. Okay. So NASA wants other players to get involved to lower costs. And in order to do that, they encourage other companies to build other situations, like the Boeing Starliner. This did not work well this summer, and they're reworking this, but this would have been the crew to do this. So they want to have commercial companies because it costs so much to go up, and they want to save money and encourage entrepreneurship, which is a good idea in America. And this all leads to SpaceX, which is a private commercial enterprise with 7,000 employees. SpaceX was founded in 2002 by Elon Musk, who started PayPal and Tesla Motors. He's the world's richest man and is worth $200 billion, and put his own money into SpaceX. And he's a visionary and has a lot of really, really advanced ideas. Here he is in front of his beloved Falcon 9 that we'll get into. But he's very futuristic with big-minded plans and wants to launch about 4,400 satellites around Earth. He uses high-speed internet, and has sent hundreds up. There was the space launch just last week that sent up 58 of these things. And he's got hundreds now in orbit trying to encircle the Earth with these satellites with this Starlink idea. So he wants to be able to send rockets to Mars and help build a space station up there, and supplies for lunar orbit, to put in lunar orbit, and help the NASA Gateway project, and to take stepping stones to land on Mars this decade. One of the problems with space travel is it's very expensive. So the costs have been coming down from very expensive. A kilogram is 2.2 pounds, and the costs have dropped. And with SpaceX, they can do it for about a third of what NASA could do. But NASA is able to charge, its program is so big that it charges a lot of money, and they want this to actually go down in cost from maybe hundreds of dollars per kilogram, or 2.2 pounds, down to a few tens of dollars, down to a few dollars. So let's talk about what NASA charges. For this pound of walnuts here, well, that would take to get into low Earth orbit, if you wanted to put that there, that would take $11,000 to put this on the space station, 250 miles up. And for this 1 pound package, it would take $110,000 to put on the moon, and $1 million to put on Mars. So that's right now. So that's what it would cost for NASA. Now, to be more practical about it, like this gallon of water, which will come up over and over in this is 9 pounds. I'm going to leave it here. This will cost, for NASA to put it up, $100,000 to put in low Earth orbit, $1 million to go on the moon, and $10 million to go to Mars. So it would be very expensive getting this gallon up, and the cost will probably be doubled by the time they really want to go to Mars. So it's very expensive to put this 9 pounds on Mars currently, and they want to lower the cost. That's the whole point of this whole thing. It's really about following the money. And SpaceX wants to take steps to fly to Mars and eventually colonize it. And the first steps concern the Falcon 9, right here. It became the first commercial spacecraft to deliver cargo to the ISS and to safely return cargo back to Earth. It has 9 Merlin engines on it and can take 50,000 pounds, which is 25 tons, up into LEO, and can return 6,600 pounds back. SpaceX uses the Falcon 9 to deliver and resupply the ISS, and has done so 25 times in the past. Many of us have seen your spacecraft launch from our backyards, for instance. It's now taking astronauts to and from the ISS. It's an orbitable, reusable rocket. Its height is 230 feet, and the diameter is 12 feet. It runs on kerosene. And this is how the Falcon 9 is transported. Here it is going up. Here are the engines, the 9 Merlin engines, and it can land its own boosters with as many thrusters on it back on barges on the ocean to save money. This is one thing that NASA doesn't do very well. Here are the Falcon 9 engines that generate the power on this. And if you put a capsule on top of the Falcon 9, it becomes a Dragon capsule and is used to take astronauts and cargo into LEO and for ISS resupply. And it looks like this. And this is it docking with the space station to deliver astronauts or cargo. This is the Falcon Heavy, which is the next one in line. It's really a Falcon 9 with 2 strap-ons with a total of 27 Merlin engines, shown here, and can carry 120,000 pounds into LEO, about 60 tons, which is its payload. The Falcon Heavy can lift the equivalent of a fully loaded 747 jetliner with passengers and luggage to LEO. It uses kerosene as fuel and generates 5 million pounds of thrust, and is 230 feet tall, and its diameter is 40 feet. And they did test this in 2018, and they put Elon Musk's car inside of it with a mannequin to be sure it can do something, but they haven't used it currently. So that's been one of the problems about this. They haven't used it as of yet to take anything to Mars or any kind of protocol yet up there. This is what it would look like blasting off. The 2 boosters fall off, and that's what it would do. So SpaceX plans to have an unmanned Red Dragon to Mars in 2024 to test heavy payloads here, possible cargo flights to Mars to provide a base, and first humans on Mars by 2026. We'll go into this in detail now. And these are the types of rockets that's going on. The Falcon Heavy, 54 tons, and as well as the other rockets that we use, like the Atlas and the Delta Heavy. This is the Atlas, by the way, here. This just launched last week. This is called Lucy, and it's going to launch from Earth, and solar powered, and it's going to go 600 million miles out where asteroids are between Mars and Jupiter, and go out there and look at about 8 different asteroids that are the foundation of how we think our solar system was made. In other words, it's going back in time, looking at how things first developed. So these are the rockets. This is what China and Japan use. And stepping stone SpaceX plans for Mars include sending an unmanned Red Dragon to Mars in 2023 or 2024 to test heavy payloads with the Falcon Heavy. The Red Dragon will land on Mars, take soil samples via a robotic device and check for water content, then blast off from Mars and return to Earth with Martian soil to Earth to provide a base starting in 2024. They'll take samples, bring it back, and so they can be analyzed where a good place is to have a colony. And then it wants every 2 years to take cargo up with the first humans by 2026. The first big test is to be able to take the heavy payload and land it on Mars, because the atmosphere is razor thin. The heavier the weight or load entering Mars, the more likely it will crash. So when you come into Mars, it's 7 minutes of hell, because there isn't any atmosphere, so you go down super fast, and that's why we've had a lot of probes that have broken up landing. But you need thrusters to be able to go down, to push up as you go down. You might even need a parachute. The only thing we've landed this heavy is a Perseverance and Curiosity, which weighed a ton each. But this will weigh about 10 or 15 tons with everything involved. So it'll be a big experiment to see if they can do this, and will look something like this on Mars. this is how they would prevent a crash doing this. Of course, using these kind of thrusters, I guess this is rocket science, when they say this isn't rocket science. Anyway. So these are the rockets that SpaceX will use. The Falcon 9, 22 tons, Falcon Heavy, 54 tons, and then there's the Mars vehicle, which will take about 100 tons out to Mars, and it's called the ITS, or Interplanetary Transit System, or AKA Starship. And this Starship will be as wide as the ISS. And it will be 230 feet, I'm sorry, I lost my notes here. Falcon 9 delivers on the Yellow, the Falcon Heavy will take cargo to Mars, and SpaceX will use a Starship to carry crew and cargo to Mars. So it'll be as long as this. It'll be 394 feet tall, or 30 feet in diameter, and its payload is 100 tons. Plus, envisions this to take 100 people to Mars in 80 days for one ticket to cost about $200,000. However, we know of no way to get to Mars in less than 6 months. So the Starship spacecraft is designed to carry both crew and cargo to the Moon, Mars, and beyond. The Starship orbital launchers will use super heavy rocket boosters to propel it to deep space and Mars. This will be the Raptor engine, providing 2 million pounds of thrust compared to the Merlin engine next to it. So this is what it will be taking the Starship up into space. With the business plan about this, it plans on blasting off from Earth. Well, they've had a booster on the bottom of it. This has been changed. But anyways, they want to blast off with the Starship from Earth and then get refueled in orbit. It's called in orbit refueling, and they want to fill it with methane, which is CH4 and O2. CH4 is over here, hydrogen and hydrogens, and they want to refuel it up here to be able to take more cargo out there. Because it'll use half its fuel getting out of Earth, and so they want to refuel it up here. It'll fly to Mars in about 6 months and come into the Martian atmosphere, but it's not clear what kind of heat shield that they have coming into the atmosphere, and then land upright on Mars, and then be refueled with carbon dioxide from its atmosphere, as well as O2 from the carbon, from the methane using they have there. So it'll be a shoot. I'm sorry, I take this out. Can you help me out?
Yeah.
Shoot. I apologize for this. I didn't see this.
It should go right there.
Well, I know.
Turn
It
it
should.
right back.
I'm so embarrassed. I'm so sorry. Let's see if it'll come back on. It won't go that way again.
Awesome.
Right.
I apologize. So that's what they want to do. Excuse me for that. So it'll be a propellant plant on Mars, making liquid oxygen, and to be able to get hydrogen out of this situation. So they'll have to have a major plant on Mars. This will take quite a bit of energy. As I said, it's you'll have to be able to do this using quite a bit of different kinds of energy. You have to cool the oxygen to be able to get it to that low of a temperature, as well as the hydrogen to be able to use it on a space flight, and as well as to be able to get some of the oxygen out. You're going to have to break down other chemicals using a lot of heat. So the plan is to, we're going to go into about this in a little bit. The plan is a trial and error basis and an ongoing delivery basis. We're about right here right now. And then to get one ticket for less than $500,000, and want to have 1 million people be on Mars. That is the plan. We're going to get into this right now. This is the ITS fuel tank that would fit inside the Starship. It's quite big. And this will be inside the Starship. The first top third of it will be where people will be, and the crew. And it will look like this. And this is the envision of what's inside of it to travel to Mars, special seating arrangements and things, and laying down, and it will look like this on the inside of it. And it will look like this, the top part of it, having different areas to do things in. Musk wants to make this like a cruise ship experience, and wants to take about 80 days to get to Mars, and I don't think so. And even wants small habitation modules to live and sleep in, and even an exercise area, and a place to watch TV, and all these kind of things. So this will be inside of it. It'll be propelled by methane and oxygen. It's a propellant. It will be kept down here, and of course people will live up here. So they want to take subsurface water ice on Mars and atmospheric carbon dioxide to be able to get the oxygen, and then convert that into fuel. They want to build a methane propellant plant on Mars and test this out. Because it's really not to be able to take to Mars and then land there and then come back. That's why we have to refuel up on with this particular situation. A test drive of the Starship will start in 2023, taking civilian astronauts for a week-long flyby around the moon and back to Earth, culminating then in future astronauts and cargo to the moon. Just about 2 months ago, they had the Falcon 9 take a couple astronauts around the Earth a couple of times to test the Falcon 9 around it. But the spaceship has blew up back last year about this time and back in February, so they're still retesting it. So to have this going on. These are the old timeline to go to Mars. Our cargo missions, they wanted next year to have cargo ships on Mars and to check out water resources there, and then set up infrastructure on Mars at this time with the Falcon Heavy, and to be able to deliver cargo. And they wanted people on Mars by this time, by 2024, and more equipment and a propellant production plant, which I mentioned here, and to build up a base for expansion using the ITS. This will not happen for a number of years. So the Starship, again, and the Falcon 9, or looking at it differently, the Starship will be 394 feet tall, and the Falcon, the simple one, the Falcon 9, and then the Falcon Heavy. This is an astronaut on the ISS in very cramped quarters, as you can see. And SpaceX has plans to colonize Mars. Let's check into this. So Elon Musk has a lot of these high-minded, ambitious ideas, which is good. And he wants to use this rocket here, compared to the Saturn V that took us to the moon. So he wants to have 10,000 trips of 100 people per trip, using 1,000 ships to populate Mars to around 1 million people. It would take 40 years to 100 years to achieve this, or by the end of the century. In the 2050s, he wants to start colonizing Mars. Therefore, on Mars, we need to have our own food, oxygen, fuel, energy, and water to make from the planet itself. So these are his ideas about going to Mars. And in these kind of ships. I've often wondered, though, about the practical end of this, because I do like being a cheerleader for SpaceX and NASA, but I have to bring in reality in this. We all do. So how are you going to get down from the ship? If you're up here, what kind of ladder situation are you going to have? Remember, you're going to be in a very bulky spacesuit. So I'm not clear how they're going to get cargo or anything down on here, being straight up like this and landing like this. But that's another situation to accomplish. And for a colony on Mars, they want to use the Starship, and this is what it will look like, a base on there. They will start with a base on Mars here, more here, and the start of a colony here. More ships, and the start of a larger colony, and this here. And a better detail of this would look like this, where the spaceships will be here ready to blast off, to take cargo and crew back, and land on Mars. And these areas right here, the green are areas where you can grow plants in, using the greenhouse, which we'll talk about. So it'll look like this, growing, growing, and growing. That's what the plans are for going to Mars. And will look like something like this, is what the future will look like. A location for Martian settlement based on water content and soil will be picked. We assume on flat land near the equator, where it's a little bit more stable. For maximum solar power production, it must be near an underground frozen water source to mine it. This ice, when melted, will help make propellant fuel, oxygen, and obvious hydration needs. So when we colonize Mars, all these areas like shelter, area, air, water, food, is of utmost concern. So we'll be taking the Starship out there, which looks like this. It has not done well in tests. And could look like something like this in the beginning also. The red dragon landing on it. And there's going to be a lot of problems colonizing Mars. You bet there be. Okay, first of all, Martian shelters or habitats need to withstand negative 50 degree below zero temperatures at night. The shelters would be made of printed material and that they could print on Mars, 3D printed. And it would look like something like this. They would need tens of thousands of square feet of solar panels on Mars to be able to have enough energy to be able to do all this. On the ISS, there's 27,000 square feet, but you're going to need quite a bit of more of that on these to do that. Now you might want to put Martian soil on top of your habitats like it did on the moon to protect you against the solar radiation. But you need a machine to do this, and it would have to be battery powered. To get this kind of machine up would be a technological achievement because they have to be taken in parts and you have to have batteries to run it. And it might look like something like this. Of course, if I'm going to stay on Mars, you're going to bet I want a window. That's for sure. So it might look like something like this. Remember, your house is 2,000 square feet. You're going to need many more times that, maybe up to 100,000 square feet to be able to produce the electricity that you need on Mars. To be able to heat this, light this, have enough power to do your work, and have oxygen, which we'll get into. So it might look like something like this. It might have this greenhouse, but we're not sure about materials that can withstand the solar radiation and be able to insulate this from the extremely frigid conditions at night. It might look like this with a power plant in the background. This is all very futuristic and ambitious, but it has to start somewhere. And it might look like this. Always reminds me of an ant colony. But this is what they want, is to take a tremendous amount of power to be able to do this, and to have all this oxygen here to be able to generate this. And it might look like something like this. This would cost over $1 trillion to make, and if made right now, would bankrupt our country. The whole program to go to Mars should take about $500 billion to go there and colonize it. Now, there's also problems with radiation. Taking a trip out to Mars, you have about the equivalent of 24 CAT scans, which would be 16 times the amount of radiation that we would need in about a year's time. And staying on Mars would even be worse in terms of radiation because there's no atmosphere to protect the sun's rays from coming at you, nothing to protect you from we have an ozone layer, and Mars doesn't, for instance. So you might want to live underground. Something like this would be about 5 stories tall, and we need tremendous amounts of machinery to be able to do this. This would be a major technological achievement to be able to do this, or boreholes. You need special machinery to do this. I want or bore into a cliff, but this has to be able to withstand, if you have special machines, special machines to do this, and we're not sure if the soil will be stable enough, or dig into a hillside. But I've often wondered where the septic tank would be for something like this. You know, where do you store the waste and the garbage that you have? So how they get oxygen again is they use an electrode from solar panels, and they get the hydrogen and oxygen out, and this is how it's stored on the ISS in tubes like this, where then it's given out. They also have a little nitrogen package that they keep on the ISS. So that's how you're able to do this on Mars. But on Mars, there'll be a special problem with this, is that they need to get oxygen from the air on Mars. You can't bring that kind of water on Mars. If you bring 100 gallons of water, that's 900 pounds. That's just 100 gallons, and people can use that in just a matter of a week or two by using it for their needs. So they need to be able to have water on Mars to make oxygen and to get oxygen in the first place, or use a different method that is taking significant amounts of carbon dioxide and taking the oxygen out of it to be able to do this. Now there's a device on the Perseverance to test to convert Mars's abundant atmospheric CO2 into pure oxygen as a practical on-site real-time demo experiment for future astronauts. This device, which is about the size of a car battery, is called a MOXIE, or Mars Oxygen In Situ Resource Utilization Equipment, to get oxygen from the CO2 in the atmosphere, which will be done on the rover. This is an experiment to be done on the Perseverance. It will take heat and electricity from the rover power source, which is nuclear, and heat it up to 1500 degrees, take the air, and split it into carbon dioxide into carbon monoxide and oxygen. The oxygen then could be trapped and could be used for further use for us, and be stored in special units, and as well as oxidizing for rocket fuel. And the carbon monoxide could be used as a low-performance rocket fuel. On Mars, with processing and infrastructure, this could be done with future solar panels in place to produce the electricity to break down these gases and to heat it up to 3 times that amount which your oven can heat up to. And then when the carbon is combined with hydrogen, which I have to bring along, I believe, it makes methane for rocket fuel. So the air the astronauts breathe, there has to be 21% oxygen and 78% nitrogen. And people consume at least 2,000 gallons of air a day to breathe, and about a swimming pool worth of it. So they're going to need quite a bit of it to do this, but they want to do this on-site production to see if it'll work on the Perseverance. It's an experiment on it. See if this works. And this would help get oxygen out of the air instead of getting it from water. Now, can you grow plants on Mars? It was thought that water could be extracted from the soil by heating the soil and having the water evaporate, condensed, and stored. However, this would take tons of soil to do this. But the Martian soil has perchlorate in it, which is toxic to humans at 1.5%. Perchlorate interferes with the ability for our thyroid to absorb iodine and seriously erodes metabolism. Even Martian dust is toxic because it will get into our lungs. So here we have Mark Watney, the astronaut on the movie The Martian, making plans to grow potatoes in Martian soil, which can't be done because of the perchlorate, which is a water-soluble salt. It's toxic to humans at 0.5%. Remember, it hasn't rained on Mars in 3.5 billion years, so the salt's right on top of it, right there. And it's used in rocket propellants. So the soil is not good for anything at all of that much. So you can't grow potatoes on there or any other kind of farming situation. So we'll have to do it underground. That is, with those bulldozers, again, making these kind of situations and putting tubes in here and growing plants hydroponically with water, that is, and artificial lighting. This is done at Epcot Center. You can take a tour there at Disney World. So you could do it that way. In order to power this, they might want to use these solar panels here to be able to redirect everything to one central point to make it extremely hot, to be able to have the heat to generate the power to be able to do all this and to generate the electricity to do this. like a solar array right here, is the thinking. So we're not sure if you can put a greenhouse on Mars. I don't think so at this point, but you would need massive amounts of solar panels to give you the heat to be able to do all this. And it might look like this inside a greenhouse. And there is plenty of ice on Mars, most of it locked away in permafrost, and it might be mixed with sand and gravel. And you might want to have your outpost or colony near a glacier. Well, we're not sure on this glacier if how much water is underneath here in terms of frozen water. It might be mixed in with CO2 or dry ice, and it might have perchlorate because there's soil all over it. So we'll have to find some way to mine the ice from Mars to be able to get water for us and use other ways to get oxygen and hydrate what we have. And at the Korolev crater on Mars, it's there's thousands of millions of gallons of frozen water and CO2 there. You can mine this with battery-powered machines, but it's negative 200 degrees below zero there. I don't think anything would work there that we have. And there is water on Mars, of course. And commercial break. Remember my favorite Martian? Okay, things have changed. And there's other problems going to Mars, which we'll cover right now. First of all, our muscles atrophy in space. There's bone loss and muscle atrophy because you're not really using any of the Earth's gravity to move. So they have to do exercising up to 2 hours a day there, running, using small weight machines and isometric exercises. But once they get back on Earth, they're tipsy and they walk like this because they can't walk and they fall down. So I'm not sure if you land on Mars and the first person's going to step on Mars and say, there's one small fall down, not big step for So that'd be carried out as it is. But on Mars, you'll weigh 50 pounds less because the gravity is 1/3. 50 pounds less than a 150 man-pound weight. And other problems on Mars, well, they tried isolation experiments living in Hawaii on a remote island there. They tried that living in a habitat with solar panels like this is what it really looks like. But anything can happen when you're isolating. You might have a rash. We've all had rashes. All gone to the dermatologist. Maybe stomach pains. How about a toothache? Everybody here has had a tooth problem. How do you solve those problems? So everything can come up. And then I have what I call my disaster page. Suppose. First of all, you're going to need spare parts. Every single thing you have for the plant production area, for the getting oxygen and the methane to convert it to be able to get your fuel, all that needs spare parts. You have to have redundant parts for everything. Well, suppose a man and woman astronaut hook up and the woman astronaut gets pregnant. How are you going to deal with that? Just suppose somebody goes nuts there on Mars, or has an argument with somebody, or just goes postal. Suppose somebody has a problem with a knife and cuts themselves, or even worse, does something. So there might even be sabotage. Someone can easily sabotage something on Mars, some equipment to make the whole thing just flop all over. So there's all kinds of problems, but they do screen the astronauts, but there's a 1 in X amount of times that this might happen. So far, really, the only people that have made money on going to Mars are the illustrators of these fantastic I don't know how you scoop out the Martian soil on this to be able to provide a base like this. I don't know how you get off the spacecraft either. And I'm not being sarcastic, I'm just being realistic. And again, these Martian habitats and these kind of situations. And this would be astronauts on Mars doing this. This would be them on Mars testing equipment, going for walks. Remember, if your spacesuit has a hole in it, you're going to have a problem. If that air becomes depressurized, you're going to have a major problem. So everything has to be done correctly with suits. And it would look like something like this, maybe. I'm not sure if there's ever going to be a child on Mars. I'm not sure if you want to have your child live on Mars. And we definitely want Earth independence to be totally free. That's the goal here, is to have this. And some of these colonies, and I'm about to end soon, by the way, some of these colonies have big, like domes over them, or where you plant plants with big domes over them. That would be fine, but how are you gonna make these domes? You might put them in panels that you can bring up and put them together, but I'm not sure how you would make these kind of situations. Something like this, even, that I copied off the net. You would take tremendous amount of resources, you'd have to build it on site there. I don't know of anything like this that can be done at this point right now. We could go to Mars probably with 2 astronauts, but it would be a suicide mission. They would get there in the proper amount of time, they might be able to live on it with a habitation module for 6 months, but I think when they get there, they would die within a couple of days of probably a hypothermia. We don't know of anything that can withstand those kind of temperatures, that kind of situation. Sadly, that's true. And I'm not sure how you would even build something like this. I'm always thinking of what kind of giant ladder situation you have to be able to handle this. I'm not sure. So again, I wanted to show you, and about these rovers that come on Mars. Oh, we'll get to that in a minute. But it might be something like this on Mars is what I'm thinking. This would be the more practical thing. Maybe a Dragon going down and then with 2 units attached to it, a habitation module. I would think something like that, but you need all kinds of backup to be able to handle this with oxygen, food, and water. You could have it nuclear powered, but who's gonna bring up hundreds and hundreds of pounds of enriched uranium, and who's gonna handle that to be able to put it in place to be able to start something like this? And you don't want any kind of mishaps and any kind of disaster contaminating Mars. It might look like something like this. This is the rover from The Martian, the movie. And I'm not, again, these kind of rovers would be a big achievement to get onto Mars. Here he is by his giant rover. This would have to be nuclear powered, or I would say nuclear powered to handle all this weight. And it would look like this. I imagine they would take this up piecemeal in cargo holds. And again, a Martian base would look something like this with the launch pads and then a Martian colony in the back here. That's what they want, with all kinds of panels, etc., and solar panels. So this is what we want to see, as well as future explorations on Mars. Actually, I myself am living to be able to want to be able to see this. One of my goals is to live long enough to be able to see people walk on Mars. Now, I've given this presentation in the past, and I've kind of given up in the past giving it because the goals didn't seem to reach what they wanted to say. The goals seem to be stretched out every time you hear about it, but I guess that's part of reality, is part of the way NASA is funded with a $25 billion budget, and part of the reality behind this. And I'm glad to present it to you, because one day we all want to see this, and especially this. And thank you, that is the end of my presentation.